Hello everyone. In this video, I'm going to discuss the general natural log rule for integrals. So before we jump onto the logarithmic form of integrals, I would like to remind you. So previously we have learned that if you have integral of u raised to power n du, so this is our general power form. So this integral is equal to, so you increase the power by 1 divide by the new power plus c, and where n should not be equals to -1. So this was the power rule, and the condition was that n should not be equals to -1. But what happens when our power is -1? When we have something of this form. So here we have u raised to power -1 du. So then this is our general logarithmic form. So in this case, the integral is equal to ln of absolute power of u plus c. So where u is any function of x. So I hope this difference is clear. So now I'm just going to show you the alternative form of this formula. So in the problem, so you can recognize always the form. So if we have, so u equals to fx, right? So that means derivative of u with respect to x is f prime x. So du is equal to f prime x dx. So this is the value of differential of u. So my new modified formula becomes, so integral of, so 1 over u means 1 over fx or fx raised to power -1. So du, that means f prime x dx. So if you have the reciprocal of the function times the differential of the function, so that integral is equal to ln of fx plus c. So this is our general logarithmic form. Let's do a few examples and where we're gonna use this result. So first we have integral of 3t raised to power -1 dt. So we can rewrite this as, so 3 outside, integral of dt over t. So we have a function here and we have the differential of the function on the top. So this is our logarithmic form. So our integral should be 3 ln absolute value of t plus c, because it's an indefinite integral, so we're going to add c in the end. All right, so in the next one, so we have integral of 2x over x squared plus 5 times dx. So in first look, it doesn't look like of the form like du over u. So but let's do the substitution and see what happens. So if we closely look at this form, so if we consider u as x squared plus 5, so the derivative of x squared plus 5 is 2x. So we have derivative on the top, and that is our logarithmic form. So there are two ways to do it. So first is the longer way. So I'll show you step by step. So let u is equal to x squared plus 5. So this means du should be 2x dx. And when we plug in the values, so we see that our integral becomes, so in place of 2x dx, I'm going to write du. In place of x squared plus 5, I'm going to write u. And the answer should be ln of absolute value of u plus c. And in the end, we plug back the value or in terms of original variable. So u is x squared plus 5 plus c. So this is our u substitution form. You could have done the same problem by using our shortcut method. So you could have recognized this form. So reciprocal of a function times the differential of the function, so that integral is equal to ln of the function plus c. So in this case, we notice this is our function, and on the top we have the derivative of the function, so differential of the function. So what we get here is, so the answer should be ln of the function, so ln of the absolute value of the function plus c. So we can just use the general logarithmic form to write our answer. All right, so let's take a look at this example. So we have integral of 6t square minus 12t, and in the denominator we have t cube minus 3t square plus 16. So first thing we notice that in the denominator, so we have t cube. So when we take the derivative, it should be 3t square. And for negative 3t square, the derivative should be negative 6t. So it means we can make the form, this form. So 1 over fx, and then differential of the function on the top. Integral of this is ln of fx plus c. So it looks like we can make this form. So one method is you can choose u equals to this and then figure out du dx, du in terms of dx, and then plug in the values. Or the shortcut method is you can rewrite this as, so t cube minus 3t square plus 16. So since in my mind I can think of that, so u is t cube minus 3t square plus 16. So du should be 3t square minus 6t. And I can see that on the top, if I just take 2 as a common factor out, so inside we are left with 3t square minus 6t dt. So I have this form now, that we have differential of the function on the top and the function itself on the bottom. So it means our answer should be ln of fx. So I'm just going to rewrite here. So this is our function, and on the top we have differential of the function. Differential of function. So our answer should be of the form ln of absolute value of function. So absolute value of denominator. So t cube minus 3t square plus 16 plus c. So this is our general log form again. All right, so in the next example we have integral of x cube minus 2x over x squared dx. So we see that there is a single term in the bottom. So first thing is, whenever you have something like this, you need to do some algebraic simplification. So we're going to split this into two integrals. So x cube over x minus 2x over x squared dx. So when we divide by x here, so we get integral, sorry, this is x square. So we get integral of x minus 2 over x dx. And integral of x is just x square over 2 minus 2. Integral of 1 over x dx would be ln of absolute value of x. And then since this is an indefinite integral, we're going to have plus c in the end. So the gist of this video is that if you have something of the form integral of a function and the derivative of the function dx, so then that integral is equal to ln of absolute value of the function plus c. So this form makes it easier to solve some problems. Just recognize the form. I hope that makes sense. And if you like this video, please hit the like button, and I'll see you in the next video. Bye for now.